Hello everyone. In this video, we will be finding the solution for an algebraic equation using the false position method. The algorithm for the false position method is the following. Step 1. Define the first interval xl and xu such that solution exists between them. We could check that if we multiply the f of x sub l and f of x sub u, or basically inserting the value of x sub l into our equation and then getting their values, the product of these two must be less than 0 or in negative sign. In this case, we could assure that the root or the solution lies between them. Usually, the interval is given on the question or with the problem, or if not, we could do this step. Step 2, compute the first estimate of the numerical solution x sub r using the formula, what you see on screen. X sub r is equal to x sub l times f of x sub u minus x sub u times f of x sub l over f of x sub u minus f of x sub l. We have the conditions, like in the bisection method, that if the f of x sub l multiplied to the value of f of x sub r is negative, the solution lies between x sub l and x sub r. Therefore, on the next iteration, we should change the value of x sub u. On the other hand, if their product is positive, the solution is between x sub r and x sub u. Therefore, we will change the value of x sub l in the next iteration. Step 4. Set new intervals based on the conditions given on step 3 and repeat from step 2 until we arrive to our solution, knowing that it is complying the specified tolerance or error bound of the problem. We will now be proceeding to our example. In this series, we have 4 different methods to tackle, in solving or finding the solution for algebraic equations. And this is the f of x is equal to x squared minus 2, or basically this is just x is equal to square root of 2. Therefore, we are going to find or estimate the value of square root of 2 using the method of false position in this video. First, we need to have the first interval. We'll be trying to start with the intervals from 1 to 1.5. So our f of x sub l, putting the value of 1 into this equation, 1 squared minus 2. So 1 minus 2 is negative 1. Then f of x sub u is equal to 1.5 squared minus 2 is 0.25. What you see on your screen right now is the table that we'll be using here as we go on solving using the method of false position. So we could clearly see the values and the iterations that we will be doing. We have already solved for the x sub l, x sub u, f of x sub l, and f of x sub u. So we might as well put the values there. X sub l is 1, x sub u is 1.5, f of x sub l is negative 1, then the value for the f of x sub u is 0.25, and then we'll be solving for the value of x sub r using the formula given by the false position, which is this one. When we substitute the values of the variables on this formula, we'll get the x sub r as 1.4. Try and solve it on your calculator, and let's see if we arrive with the same answer. So changing that in our table, 1.4, and then if we insert the value 1.4 into our equation x squared minus 2, we will arrive on the answer 0.04. On the next iteration, we need to notice that the product of f of x sub l and the product of n f of x sub r rather is positive, because negative times negative will have a positive sign. So on the next iteration, we will be changing the value of x sub l from the value of x sub r. It means that the 1.4 will be our new value for the x sub l. I've already completed the table, repeating those steps, and at our third iteration, we have already arrived to the value of x sub r 1.4142, which is the square root of 2, or the value of square root of 2, up to 4 decimal places. If we substitute this value on our equation, we will get the f of x sub r 0.0000 in 4 decimal places. There will be some values if we will write this with more decimal places, but up to 4 decimal places, which is our tolerance or error bound, I think this is like the best solution that we could get, because they are really the same with the value of square root of 2 up to 4 decimal places. And we also could notice that at our third iteration we've already get the value. Therefore, comparing it with the other methods that we have done in this series, the method of false position is actually fast in getting the value of the root. And at this point, I think we have just solved it.